supposed to clap till we're done. And you might not want to, yeah, right. So thanks for joining us today. As mentioned, we're going to talk about fingerprint readers, specifically the APIs for iOS and Android. And I'm so going to screw that up. Let's just clip that on. And how they're used, how they can be used poorly, and some ways to bypass them when you use them poorly. So this is me. I've been around for a while, been with OWASP for quite a while, been doing consulting, specifically AppSec for years and years. The VP Solutions at Invisium. I hack and I golf, and usually at the same time. I even golfed in Rome, which was kind of cool. So this is going to be weird.
We're going to try to make it not super weird. Maybe I should hold it further away from my face. So that's me up there, Jack, the CEO at Invisium. Some days I have to work in spreadsheets. Some days they actually still let me write code, which are good days. Has anybody actually messed with Brillo yet, by any chance? Brillo is really cool, and it's going to be everywhere, and it's going to be great. Spend a lot of time messing with Brillo, a lot of Spark, Akka, Kafka stuff these days. Again, when they let me out of my hole. So I'll turn it back over.
So before we dig in, I like to kind of know who my audience is. Who here is a developer, specifically mobile developer? Wow, 3? Is everyone a hacker? What do you all do? Just yell it out. So we just come to conferences and do nothing. Great, cool. So this is how we want your mobile apps to be, right? We want this fantastic castle, like some of the things downtown here in Rome that are seemingly impenetrable, right? And not something like this. Like we don't want to go back to BC and have some issues and redo Lord of the Rings and all that good stuff. So one of the things we think about when we think about securing mobile apps and so on is fingerprint readers, and that's why we want to get there today. But before we get there, can anyone tell me what this is, number one? Okay, that's the easy part. Where is it at? It's a vault. Everyone always guesses Fort Knox. It's not Fort Knox. Okay, this is in the depths of the Federal Reserve in New York City. This is the vault that houses gold for pretty much every country but our own. But anyway, the reason I bring this up is this is because how I think about mobile security and specifically the fingerprint readers on mobile devices. I look at this vault and this is a massive structure, massive door, and the only way to open and close this door is with 2 people that have to turn each one of those things, and it rotates, and it closes, and it opens, and closes, and opens. The way I look at fingerprint readers and mobile security is instead of this massive door here, it's just like a screened-in porch. It's very easy to get through, but we're not thinking about that from a security perspective. I got the little thing, I'm good. Disclaimer, you guys have all seen all that. So today we're going to talk about biometrics for mobile specifically, use cases, iOS and Android APIs, history, show some examples, show some bypasses, and then good ways to do it, because there are good ways to use fingerprint readers. So what are use cases? Anyone using these in any of their apps? Well, I mean, there's 3 developers, so. Well, we all use it for authentication, right? We'll talk about that. Either authenticating to the device, maybe to an application, maybe it's used for performing sensitive functionality, right? Maybe it's used for, client-side lockouts or something like that. There's quite a few use cases, and now that Apple was kind of the pioneer, if you will, whatever you want to call it, because they acquired Authentic in 2012, right? And everyone's like, oh, wow, we're going to have all these awesome fingerprint readers. And sure enough, the next iPhone 5S they released, there it was. Oh, but by the way, you can't use it in your apps. What? No, it's just for the phone, right? Thankfully, after a year, they got smart and they said, okay, now you can use it in your applications. We're going to provide APIs to do that. They've actually done some good things, and we could spend a week or more talking about how they secure the fingerprint data and all that. They use the secure enclave, and I'll talk about that a little bit as we go on. But if you want to know more about that, we can talk later. So in iOS 8, applications could now use it, right? Everyone got excited, and every app, Amazon, American Express, all of them were starting to use it without thinking about what that meant. Well, in iOS, there's two ways to do it, and we'll talk about that as we move along.
And as for Android, Marshmallow is when they first introduced native APIs. So previously before that, Samsung, some other vendors had implementations, but those were device and hardware specific. So in Android 6, Marshmallow is when Android first introduced the native APIs. So unlike Apple, you had programmatic access from day one. In terms of the implementation and integration with the trusted execution environment, we'll look at that a little bit more, but that's a really fundamental part of just the implementation itself. So there's some secure parts of the hardware, specifically like system on chip types of things, and we use those to store sensitive keys, and we never allow the actual fingerprints in plain text. In a perfect world, not to say this doesn't happen, but in a perfect world, you never acquire those samples inside of the regular environment. You always want to acquire those things inside of a trusted environment. So think in terms of mobile malware, something that can, just dump memory, root access, right? The goal is you want to protect against those types of scenarios, and think of it in the threat modeling kind of way. You never want to allow an application in user land to be able to dump memory and pull those fingerprints. So it's really important that you acquire those things in a secure way. And if you pass those back to the regular operating system, you never pass back plain text samples of those things. In terms of the key store and the key master service, so Android gives you, especially in Marshmallow, so key store has been around for a little bit. Android hardware-backed storage has been around since 4.3. But it got a lot better in Marshmallow. So there are a lot more cryptographic primitives and things you can do that just didn't exist prior to 6. In terms of the general ways you'd kind of go against, bypass these implementations, especially from developer-introduced issues, it's a similar bag of tricks. So when we do the demos today, we're not going to do each one for iOS and Android because there's a lot of replication. We'll just kind of talk through the differences.
So Touch ID technology itself is pretty important in the overall scheme of things. Same thing with Android, but it's built into the iOS device. Obviously, it's a sapphire crystal surface to help resist scratches and things like that. Uses capacitive touch like we're used to, but the key here is that actual Touch ID sensor is tied at the hardware level to the chip. So whatever A number chip is on your device. So I get the question, hey, well, I could probably just steal the fingerprint data. Well, number one, that data it's some hashed form that's IP that they won't release, right? But that data is on the chip. So I could steal the chip and put it somewhere else and maybe try to get at it. Well, no, you couldn't, because that chip is tied specifically to the reader itself. So you need them both somehow, right? You can't just replace one or the other and try to get access to that hashed value of whatever they're hashing. So how does it look in iOS? Like I mentioned before, there's two ways to use the fingerprint sensor in iOS. But before we get to those, you set it up at the iOS operating system level. So remember that, because we're going to talk about that a little bit as we go on. So to be able to use Touch ID in your application, the user of the phone has to have set that up at the OS level, okay? And it's a yes or no technology because all of the validation of that fingerprint is being done within the secure enclave, and it basically responds with yes or no, or maybe an error if something went wrong. And there's two ways to do it, LA context and user presence, and we're going to talk about both of those. So this is the typical code. Hopefully you can see that. So this is what I usually see when I'm looking at mobile applications, because frankly, the documentation that Apple provides is an application. There's really no good documentation of how to use these APIs and what it means to you. But this is what I usually see, and I'll kind of walk through this quick. So we're going to use your LA context. You're going to check to make sure you can actually evaluate it, right? Well, if they haven't set up Touch ID, it's not going to work. So you got to make that check to make sure that that's set up. If it's set up, I can evaluate the policy. And as you can see here, it evaluates the policy, and it's going to return a success value and maybe an error. That's it. That's all you get from the secure enclave. And actually, there's a whole path that I'll talk about too. And then if success, do something else, right? User presence is a little different. User presence is used with the iOS keychain. Okay, so you can store sensitive data in the keychain, which is also managed and stored within the secure enclave. And it has to be accessed through the use of your Touch ID. So Apple, with iOS 8, they had one option. It was either on or off. So one of the attributes was the KSEC access control user presence. With 9 and now 10, which I'm disappointed at, it looks like these are the only options. And we'll talk about a couple of those as we move on.
We only have one of these things in case you guys didn't notice. So what's a trusted execution environment? So Android provides a mechanism where really the hardware manufacturers do, which allows you to basically run secure operations isolated from the main OS. So this is really similar to the concept behind the secure enclave. But taking a look at, for example, what's on the left-hand side here. So this is the main OS, right? So think of your Angry Birds and applications like that. They're going to run here, right? You're generally not going to run Angry Birds inside of the trust execution environment. So within the trust execution environment, you're generally going to be running native code. It's a little bit different in terms of memory access. So in theory, an application running here is never going to be able to touch the memory here. Whereas if anybody's familiar with, for example, there was a QSEE exploit about a month ago. So Qualcomm's secure execution environment. So they basically were able to pivot through I think it was the Widevine application. So there's a handful of applications that can actually, at a low level, communicate here. So exploited that path, and pretty much if you can own an application here, it's somewhat game over-ish, right? So that's exactly what happened. So Android provides that mechanism to kind of isolate those things, and you should do things like crypto and whatnot inside the trust execution environment. And here's kind of what it looks like in terms of architecture. So above here is the trusted execution environment. So this is all trusted. Below here is userland or main OS. So if you're doing traditional PIN password stuff, you're going to go through the Gatekeeper D service. If you're doing fingerprint related things, then you're going to go through Fingerprint D. So kind of going up a little bit here, there's a handful of different things that aren't in here that will give you somewhat uniqueness per device. So for example, you'll have like a device ID that kind of gets dumped into how you actually encrypt those fingerprints. It's actually global per device, so you're going to have a device ID. You have some other things that feed into that, but one thing that's interesting is Android allows you to have multiple users and multiple fingerprint sets. So on iOS, you're going to have pretty much one user, whereas Android allows you to toggle between users, and you'll have like 5 fingerprints per user. But just some of those things that kind of feed into how those things are protected between environments are going to be like device global, right? In terms of what Android provides to developers, here's pretty much the primary things you're going to be able to call. So the fingerprint manager is what you're going to use for a lot of stuff. For example, do you actually have enrolled fingerprints? So if you don't have enrolled fingerprints, then you have to force the user to go through the flow and actually submit those. If you don't actually have a lock screen set up, right, with a pin or a pattern, then you're going to force the user to that as well. The other things beyond that, key store and key pair generator, we'll take a little bit of a look at. But those are some of the really powerful things that you can kind of hook into these implementations to protect you against the things we're going to talk about in the next couple slides. Here's one example, right? So if you have a new user, first thing you want to make sure they actually have a fingerprint reader, right? Is a part of it. If they don't have the fingerprint reader, you don't have the permissions, then there's not much you can do at that point. Down here is really generic implementation with authentication. This right here is generally what you're going to be doing like your callbacks from. So you can do like callbacks and handling things. So for example, success, failures, errors. It's going to be like this one right here. So demonstrations. So there's a couple ways you can do things, right? So there's hooking into Touch ID keychain on iOS and on Android. You can leverage the keychain. A lot of developers don't actually do that. So we're going to show an Android example, and we'll show an iOS example of like trivial bypasses. Like it's not sexy at all. I'm going to wait till that comes up. So this is one, actually seen this, I can't tell you how many times already. So as everyone's probably familiar with that knows Android, IPC is a big part of things, right? So one component can talk to another component, and you can start things that maybe shouldn't be started in a certain order. So you can export components, which means that, for example, another application potentially can invoke something in your app. And we can abuse that, right? So in this example here, we basically say, okay, to unlock it, you need to provide a fingerprint, and you can use ADB to actually send that, but we're just going to kind of go around it. So what we did there is we basically just basically request to call the home activity, and we just completely sidestep the need to authenticate to the device with a fingerprint, right? So this is a really vanilla example. But if your application, if you're using it to just basically get that warm and fuzzy that the person is sitting there should be, right, that's great. But if you do have a rooted device, so that is a caveat. You don't actually, in this scenario, have to have a rooted device. So in this scenario, you just need to have, some kind of ADB access, right? Or an unlocked device, and you can pretty much sidestep this. So everybody kind of see how that worked. It was just a simple, basically, call to an activity, and we went to the home activity and completely bypassed authentication. Really vanilla, but like developers do this, and it's not their fault. They just do these things.
So with iOS, I'm going to show you a couple examples of using LA context that are from actual apps that I've assessed, and what's potentially bad about them. And then I'll show you a demo that is a little more in depth, how we would do it in iOS to bypass this. But basically, this is the typical flow, which I already saw. You evaluate, or you check to make sure there's a reader and it's been used or set up, and then you evaluate the policy. Now remember, this is a yes or no technology, and it's set up at the OS level. So what does that mean? Because I can set up multiple fingerprints at the OS level. It's exactly. So you can't actually use it as authentication. You don't know who's actually touching Touch ID, right? So we could all set up your fingerprints on my phone, and you'd all be able to log into my Amazon account, my American Express account, and all that, because that's all it knows. Apple doesn't provide any insight into whose fingerprint it actually is. So that's point number one, and Android is similar to that. So example two, from what I've typically seen, you've already seen that one, the typical if error, if success, do something, run some other class, method, or whatever else. And then the other one is aha, I got you. I'm just going to call a bunch of built-in iOS classes. But they all follow the same pattern. Remember, I can run things out of order, right? If I have a rooted or a jailbroken device, I can run all this stuff out of order. So in reality, none of this stuff really matters to me at that point. So let's see what that looks like. If I can get my mouse somewhere. Okay. So what I have here is a really shitty app that I wrote. Like seriously, don't have me code for you. That uses those three methods. I'm just going to show you one of them, and I'll show you over here kind of the process I go through. The first thing I do is I use iProxy. Anyone use that? One? So iProxy is great. It's part of the Lib mobile device suite. It allows me to proxy traffic through USB, so I don't have to worry about someone at a security con trying to hack into my network while I'm trying to do demos. Well, I got over that, and I just recorded them anyway. So I'm going to connect to the phone, and then I can SSH over USB. Okay? And then I'm going to connect to my phone, and I'm going to use SciCrypt. Anyone else use SciCrypt in here? Okay, good. So I'm going to connect to the actual process that's running of my really crappy app. Hopefully you guys can see that, but it looks really not good. So I'm going to connect with SciCrypt, and I'm going to try to figure something out about my application, kind of where I'm at in the app. So that's really what I need to know. I need to know what the current view is showing on the screen. So I'm doing this kind of as a black box. I don't really know. I don't have the code. So I need to figure out where I'm at. But this is how it looks. You touch it, it says, hey, yep, success, you're good. And then you can fail as well. Fail out of it. Like I said, it's really simple, just success or failure. So what I'm going to do is I'm going to try to figure out with SciCrypt where I'm at in the application by looking at recursive description and picking one of the memory addresses, right? So I pick I think I picked one of the views to figure it out. And then from there, I can start getting the next responder, right? For those of you that understand iOS and kind of how it works. So I can figure out what that current view, what I actually see on the screen is. So I'm going to get the next responder of the memory address that I picked from this ugly output. And that's a UI view, so that's not really what I'm looking for yet. I need the controller piece. So I'm going to get its next responder. And there it is, UI view controller. That's the one I want. So now from there, I can start figuring things out like the methods that are available within, yeah. Can you speak up? Sorry, I can't hear you. Yeah, it's a recording, so I don't know if we can zoom out or not. Sorry. I can, if you want after this, come up here and you can see it on my machine. But so I'm getting the methods that are available to me. Why is that showing up? You broke it, Jack. Here, let's rewind it. You're screwing me up. Here, let's go back a little bit. Oh, that's why. Can't even do recorded demos anymore. So anyway, what I did here is I got the next responder, figured out what the current view was, and then, so SciCrypt gives you the ability to use JavaScript and Objective-C. So I have a JavaScript method that I uploaded into my SciCrypt instance called print methods. It's available online, iPhone wiki. It's great. And I can print the methods in any class. So I print methods in view controller here, and then they print in a way that you can't see because this is frozen. And from there, you kind of have to start doing guesswork, right? Honestly, it's usually pretty easy because as developers, we like to name things that make sense. Or you might be told that you have to name things in a certain way. So there's actually one in here called show local authentication result, right? So that one's interesting to me because that, to me, says that's going to do something after I've done the fingerprint. And when you see this output, you can see that it takes 2 parameters. So that's when you kind of start guessing. So I first guessed, true or false, and that's when you saw the error. It errored out. I wasn't able to access the prompt. So I tried again. Null's always a very fun value to send to these. So I sent true and null, and sure enough, I've now passed that whole authentication piece. I don't even need it. Okay? Let's see if we can even get out of this. Hey, we did. All right. Any questions on that? We got time. Sure. I can't hear you. You guys are gonna. It's. Oh yes. Yeah, watch. Anyone use this? Come on. Use Ionic or Cordova or PhoneGap, whatever. You're using this, right? Does that look familiar? It's using LA context to evaluate policy in its provided API to use the fingerprint. Okay? Now, the argument is, but, you gotta use a jailbroken phone, blah, blah, blah. I don't care, there's a better way to do it. Why wouldn't you do it that way? And we'll talk about that. So, solutions. If you absolutely have to use the LA context evaluate methods, there's kind of ways to do it with security by obscurity, okay? You can define private methods, but in reality, they're not really private, right? For those of you that do a lot of Objective-C. You can try and avoid static discovery. So as you might know, Objective-C is a statically discovered language, right? You can discover all the methods, class names, and all of that by just running strings and all that against the actual binary, okay? But the way you can kind of avoid that is by using old school C instead of Objective-C. Okay, so these are going to be dynamic method resolution, kind of like Swift, instead of statically resolved. Again, this is only if you have to. I wouldn't recommend using LA context at all, to be honest. I'm going to skip this demo because, frankly, we'll be out of time. But what this was supposed to do is I showed you that print methods approach. You can, and I was going to show you print methods. If you do the static or the dynamic method resolution and you try print methods, those methods do not show up with that, okay? Because they're dynamically generated at runtime. Same with class dump and strings. You're not going to see the actual method names if you define them in that way. Now, does that mean they're not there? No, it doesn't mean they're not there at all. Again, it's kind of an obscure approach. The other way is to do pure Swift. I've yet to see a pure Swift application. Usually the bridge is turned on. Anyone test Swift with Cycrypt? Good, because you can't. If you're looking for a security company and they tell you they're just going to use Cycrypt with your Swift app, punch them in the throat and walk away. Seriously, you can't. It doesn't work. And it won't ever work. There's going to have to be another way to do it, okay? So Swift apps are harder to analyze. Runtime manipulation is very limited. There's no class dumping, because some of those out here that know, it's mangled, okay? So you can demangle it and figure some things out. But I tell you what, it takes forever to get to the point where you might even be able to do one little thing that Cycrypt does in like 20 seconds, okay? So it mangles things in this really ugly looking string here, right? But it actually makes sense. These values here mean something. T means Swift method, F for function, C class method. Here's your class name. So 8 means the next 8 is the class name, 14. The next 14 is the actual, this is the app name. Next 14 is the class name. This S, that's a setter or getter, so it's going to be S or G, right? The next 11 are going to be the actual method name, and then the return type. But you can demangle it. There's ways to do it, and it will tell you all of that right here, okay? So you've gotten to that point, which probably took you 2 days to figure out. Seriously. So that's one I want to go after. You can hook it, like Cycrypt does. But again, it takes a lot of time. So now you're at day 3 or 4 of your 5-day assessment, and this may or may not even work. It might not even be the right one, right? So there's a lot of info about Swift hooking. Maybe someday we'll have like a Cycrypt for Swift, but it's a ways away.
Thank you. In terms of Android, so we mentioned that there's definitely a lot of overlap, right? So similarities in Android in terms of being able to hook methods, you use IPC mechanisms to get around things, control the flow of execution, etc. So those are really very similar, just different platforms. Methodology is very, very similar, right? Thing you obviously see, you see it in iOS, you see it in Android implementation as well, is just kind of the logic's kind of a little messed up. So seeing applications where it's like, we don't have the runtime permission, like, don't even worry about attempting to basically get a fingerprint, right? Same thing with like, we don't have a lock screen, just basically bypass that, right? It's cool. So on and so forth, right? So there's also the logic aspect to that, where if you're not intelligent about how to fall back from those things, then you're just going to let someone just basically circumvent the need for a fingerprint. So something to be careful about. This is kind of awkward where it goes back and forth.
Yeah. I guess we can't afford 2 mics. So what's the real solution here? It's to use it with the keychain, right? And user presence. It's a simple fix. But there's no good documentation about this, like I said. The Apple documentation is, here's an app. This is how it works. So the keychain with Touch ID was also first implemented in iOS 8 with improved accessibility options. Like I mentioned before, it uses secure enclave, stores the fingerprint data, whatever that is. They say it's not the actual fingerprint, so even if you stole it, it's probably worthless. And keychain items. So what does that look like? Well, this is what Apple says. There's basically 3 different VMs, if you want to call them that. It's just whole different OS pieces. There's user land, there's the OS itself, and then there's the secure enclave, okay? So you have your apps, security framework, the sec item APIs, which are the APIs that utilize or request or set data to the keychain. And to be able to use those, they have to use the security D daemon, which then interfaces directly with secure enclave, and based on however those are set or get, it may return them, it may request authentication, what have you. So what does it look like with Touch ID? Again, it's the same thing. You have user space, the OS, and secure enclave. It's all managed still through that security D daemon. Through the sec item APIs, you just have a separate attribute that you set from your code, the attributes we showed you before. And then if you set that appropriate user presence attribute, the secure enclave is going to say, hey, wait a minute, this is encrypted, they need to provide something, and the app prompts them to touch the Touch ID. So this is what it looks like. It's very simple to use in iOS 8 and 9 and 10, and probably 11, 12, whatever. But when you set your SAC object, if you will, that's your access control reference object, you have to set the appropriate attribute. As you can see here, this is, again, the only one available in iOS 8. And then it's just like you're setting any keychain item, like you'd normally set in the past. You create your NS dictionary, set values, whatever it might be, and then they're stored. When you try to retrieve them, they're prompted to use their fingerprint. And again, since that fingerprint is evaluated within the secure enclave, there's no way to get around the actual evaluation at that point, right? Because you have to return something for the app to proceed. Usually it's a username and password, maybe it's a long living cookie, session cookie, something like that. Or maybe it's a key that decrypts the data that's on the device. Whatever it is, you can't get around that fingerprint evaluation, because that's all happening within the secure enclave. And if it fails, you don't get that data back. So with 9 or 10, they added those accessibility options. My favorite one is the Touch ID current set. Anyone have an idea what that does? So if you set that, it takes kind of a snapshot of the current fingerprints on the OS. If that changes at all, whether you add one, you remove one, that will fail the next time. So it takes a snapshot. So it's like if you log into your device, you set up Touch ID, you add your fingerprint, you install Amazon, you turn on the Secure ID. If they're using this attribute, and then say your kid or your wife or your nosy neighbor come along and add their fingerprint, they're not going to be able to get into your Amazon account because it knows that something has changed with that set of fingerprints. And the other thing you can do is use OR within these attributes in 9 and 10. So another one that a lot of folks are happy about is you can utilize a backup application password instead of just the backup of device passcode. They weren't happy about that. But same thing, in its dictionary, set the values, and the next time you retrieve it, it will prompt appropriately. You don't need to see that. So what's the question I usually get here? How do you know if they're using it or not? It's hard to tell. I mean, I can't go in and say that your banking app is using user presence without getting into the application. I can guess. I mean, the typical thing that I see for the apps that are using it is it's the login screen and it prompts you for Touch ID, then they fill in the text fields and submit them to the back end for actual authentication. Pretty sure those are probably using it. But unless you jailbreak that device and get into the actual app and hook it, you don't know for sure. But again, what's the problem? It's still not authentication. You don't know anything about the person touching the Touch ID value, right? You just know that that fingerprint is associated with that device.
So similar in implementation, Android, as I mentioned before, has pretty deep integration with the fingerprint reader stuff and key store. So in this example here, the most important piece you want to kind of focus on is implementing it with the Android key store. So if you're doing it with the key store, then you're using the hardware-backed implementation, which means that, for example, if you're generating, say, like an asymmetric pair, the private key is going to be stored in a secure way, hopefully with hardware anti-tampering mechanisms, et cetera, which is going to make it a little bit harder to kind of extract those values. So if you're doing this kind of stuff, you want to make sure that you're actually using the Android mechanism to do that. So that piece there, Android key store. So if you want to generate a key pair, right? So the part that's highlighted right there, set user authentication required. So if you want to be able to access those keys and pull them out of the trust execution environment, then you're going to actually have to authenticate every time. As opposed to if you weren't going to do that, well then you may not have to, you may be able to use it for a certain lifetime. So most important thing there is make sure that you're going to set, so for example, if it's something where you're allowing users to make purchases, you want to make sure that they're going to have to authenticate every time they're going to do that. So this is kind of a pattern you'll see where you'll generate a pair of keys and ship off the public key to a server somewhere. That private key, just like the fingerprint, shouldn't, at least the secure key should, the private key should never leave that environment, right? So the public key is the only thing that goes. So for example, if you want to make sure that, a user is going to sign a transaction, right, that it came from them, you're going to make sure, obviously, going back one, that step one, they actually had to provide a fingerprint to do it. Step two, public-private key matches, right? So that one's really important right there. The private key, I can't stress that. It's going to stay there inside of that environment. You don't want it to leave. That's kind of the whole point. Android also provides something in the form of a confirmed credential. So this was also introduced in Marshmallow, and basically the point of that is it's for user happiness, right? So think of users, especially if you think of people that do like daily deals kind of applications, right? Where you want users to make impulse buys and things like Botox or whatever. You think it through, you're like, I don't want to buy that. No. You want the user to actually like buy it before they realize it's a bad idea. So if you want to speed them through that flow, you don't want them to actually have to re-authenticate, authorize. So you can actually leverage a feature which is tied into, say, for example, a lock screen. So think of the user unlock the screen within 5 minutes, right? And you want to basically use that to further allow them to do other things, right? So you can make that easier where the user's going to be able to kind of step through that flow without providing credentials a bunch of times. So here's an example of that. And this is kind of how it's done where, I know it's probably really hard to see from back there, but essentially you'll use a key that you're going to store within the hardware-backed place. You're going to basically set a time frame on it, right? So in theory, if the user can unlock it within a given time, then you'd assume that they had, unlocked their device within a minute, within 5 minutes, right? So obviously that's a feature that developers can be really egregious with. So if you're setting that to like an hour, 2 hours, like maybe consider pulling that back a little bit. But it's there for that purpose to kind of ease the process of getting through a transactional flow, right? Cool feature, but like obviously you want to be pretty careful with that, right? So if you let that be an hour, well then, I always use my mom as like kind of the, she has a flip phone, but imagine she had a smartphone, like she wouldn't lock her screen or anything like that. So she'd be that person, right? So I want to protect my mom from herself, right? And you don't protect my mom from herself by allowing her to have an hour to go back into the application and buy anything she wants. So cool feature, but like you can definitely abuse that. On the Android side of things, I can't stress enough, take advantage of the hardware back key store stuff. It's there, it's maturing. Android N introduces things in terms of key attestation. It's really, really cool stuff. Handle exceptions, callbacks intelligently. So if there's a failure, that doesn't mean like fail open, let the user into the application, right? Take that into consideration with how you program things. Those are the big ones there. We're out of time, by the way.
4 minutes. Yeah, well, we're at the summary, so we're good. I think the biggest thing is, use some sort of user presence, right? Don't use the local authentication mechanisms. Yes, you have to jailbreak or whatever else, but just use user presence. But at the end of the day, this could be a problem for some regulations. I'm not saying it is, but it's not authentication because you can't tell me who actually used their fingerprint. A lot of info here. Actually released a blog on the iOS stuff last week, so if you want more info, check that out. It walks through that. The code's available of the crappy app that I wrote in Jack 2. And it's probably crappy. And Google samples and all sorts of good stuff. So thank you. Mobile security is hard. Try harder, please. Questions? Yeah. The question is, have we contacted Apple or Google to help with documentation? And the answer is no. We could, and we probably should. Apple won't change it. Google might, but you're right. Stack Overflow is horrible. Most of those examples are probably from Stack Overflow. And actually, a lot of the issues in code that we've looked at are third parties that provide the NG Cordova type functionality to utilize the readers, and that's where we've run into a lot of the issues.
Google actually has a bunch of samples out there in terms of if you want to do asymmetric stuff, symmetric stuff, confirm credential. There's a bunch of Google samples. They're okay. Okay.
Had one more question, I think. Right. So the recommendation that was given is to utilize it as a secondary mechanism, and I completely agree for authentication. But that defeats the marketing purpose of it. right? It's touted as easy, right? So the business sees it, oh, it's easy, so we're gonna, and users want to use it. But I get it, and I all for that approach. I've been turned down quite a few times on that. Yeah, it makes sense. I get it. Thanks, guys.